Most of us have a dream of exploring in some ways, whether it's exploring a creek when you're a child and looking for, tadpoles or life or whatever it was, or annoying your brothers or sisters, whatever it was. We would like to explore something. But humanity has had this dream of looking up at the sky at night and seeing stars for, I suppose as long as humans have existed. And it's time to think seriously about, can we actually get to these points of light that we romantically see in the sky and have so many stories and movies sort of imagining what it would be like to travel into space. And we have very rudimentary abilities at this point. We're barely getting outside of our solar system. And in order to get to the stars, we need to take a radically different approach if we physically want to get to the stars. And we observe them, we have remote sensing, but there is, I think, still a drive that we have to actually physically go somewhere. And I think this is a key in much of humanity's quest throughout the ages. So we started looking at applications for directed energy beyond our initial application, which was planetary defense. We started looking at what else could we do with this technology, which is rapidly changing and going from sort of science fiction to science fact, and is going to change dramatically in the coming decades. So we looked at what could be done, in particular in the case of interstellar travel. Was it possible to build a system that was credible and didn't invoke wormholes or warp drives or antimatter propulsion or whatever scheme that you want to think of, but actually had some roadmap on the real axis rather than the imaginary axis?
Hi, my name is Travis Bashirs. I'm on the UCSB experimental cosmology team that's working on Project Dragonfly. I go to high school in the local Santa Barbara area, and I come out to UCSB to do research on my free time. Project Dragonfly has offered me the chance to gather a group of physicists at UCSB and discuss a way to explore the interstellar medium. There's not many people at the undergraduate level that get to do this and have this opportunity. And with this prize as an end goal, it really motivates us to continue our work and finish our paper.
Hi, my name is Alex Lang. I'm an undergrad at UCSB studying physics, and I'm part of the Project Dragonfly team here at UCSB.
My name is Kyle McDonough. I'm a third-year physics student here at UC Santa Barbara. I'm interested in astronautical and space systems engineering, and Project Dragonfly is a great chance for me to work on those skills.
Hello, my name is Sebastian Arias. I'm currently a second-year physics major here at UCSB. I feel like this has been one of the most influential experiences that I've had so far. I'm extremely interested in research overall. I plan on going into research and plan on going to grad school to specialize in astrophysics. This has been an incredible experience. I love working, I love learning, and I love just getting to know so much about stuff that I could never even dream about before. I feel like it has really helped me grow, not only as a student, but also as a person.
Hi there, I'm Kaio Mota. I'm a third-year computer engineering student at UCSB, and I'm currently providing computer engineering support for this project. This project's given me a lot of good opportunities to really look into some of the fundamental issues of current technology in computer engineering. Because one of the biggest things in computer engineering right now is a limitation of power, and the other big thing is space. But for us, we don't have that much of an issue with space because we've got a pretty large wafer size. But with power, we have an extremely low power application that we need to fulfill. And this is actually a really active area of research because pretty much every cell phone, every camera, every handheld electronic device is completely dominated by power.
Project Dragonfly is a theoretical feasibility study for an interstellar mission leaving in the year 2050. There have been feasibility studies in the past for interstellar missions, and all of them have involved very large ships, which are possibly requiring a solar system-wide economy in order to actually build. We've come up with a sort of new idea, and Project Dragonfly, in fact, is based on that idea of creating a smaller ship that could be built with today or near future technology and could still allow such a mission to occur. Here at UCSB, we've come up with an idea to take that idea of downsizing the ship even farther, and we've actually come up with the idea of sending a 1 gram sized probe into space.
So our main objective for Project Dragonfly is to get to Alpha Centauri in 15 years using a laser-powered spacecraft. And what this means is we take the energy from the sun and convert it through photovoltaics to laser power and direct that energy onto a reflector on our spacecraft. This reflector could be a range of sizes, and what we're proposing for our fastest mission is a 1 meter reflector for a 1 gram spacecraft. And this will, in 10 minutes, we can get to 26% the speed of light. And at that rate, we can get to Alpha Centauri in 15 years.